So let's continue on with this question number 4. Kind of didn't see what was going on here, but I misread my parenthesis up here. That was actually a parenthesis, not a 21. So let me erase that and kind of clean this back up a little bit here. So I should erase all that first before I start my video. So what we should have had is L of x, and we had this L of x plus 2, so that should be just multiplying x times x plus 2, like that. So again, since this is a base c, we can put this in exponential form. So again, I'm going to have this x times x plus 2 equals e to the 4th. So we didn't get away with that. So we now have x squared plus 2x equals e to the 4th. So again, we have a quadratic, so it has to be set equal to 0. So x squared plus 2x minus e to the 4th is equal to 0, becomes our quadratic. We have to use the quadratic formula to solve this. So again, our a is equal to 1, our b is a 2, and our c is actually a negative e to the 4th power. So that's a little bit different. So remember in our formula we have x equals the opposite of b, so that's going to be a negative 2, plus or minus b squared, so 2 squared would be 4, minus then 4 times a, which is 1, times e, times c, which is negative e to the 4th power. And that's going to be all over 2 times a, which would be 2. So let's see what we can do. So we have x equals, we have negative 2, plus or minus, we have the square root of. So we have this 4, and notice how we have a negative times a negative, that's going to be a positive. So it's going to be plus then this 4e to the 4th. Like so, over 2. A little bit more to do. Got any more room? I got a little bit more room. So what we kind of see here is inside the square root, we do have a common factor of 4 that I can factor. So this becomes then negative 2 plus or minus the square root of 4 times 1 plus e to the 4th over 2. And then looks like I'm running out of room that way. Let me sneak it out this way a little bit. We can't go too far. Circle back around here. So what I can do now is I can take the square of the 4 and it comes out as a 2. So negative 2 plus or minus 2 square root of 1 plus e to the 4th. Don't have any magic there, just have to leave it like that. And then we have to separate that as 2 separate fractions. So negative 2 over 2 is going to be a negative 1, plus or minus. And the 2's will separate out on the second one. So 2 square root of 1 plus e over 4 over 2. The 2's will divide out there to give me then the square root of 1 plus e to the 4th. But notice again how we had a domain restriction. X has to be greater than 1. So we have to exclude that negative 1 there and just say negative 1 plus the square root of e to the 4th. So we have to throw that other one out. So our final answer is going to be then negative 1 plus the square root of 1 plus e to the 4th. So that becomes our final answer there. All right, back over to number 5. We've got a few more to do here. I've got number 5 here. So again, we do have the same base on each side. It looks like what I could do is bring this exponent in. I'll have to give myself some room here, so I'll go over to the side and write this as the log of x plus 2 squared, base 13, equals the log of 4x plus 7, base 13. And since the logs are both the same, all we have to do is set what we're taking the log of equal to each other. So we have this x plus 2 squared equals this 4x plus 7. Now, since we have a quadratic going on here, we have to kind of work this all out and start all over again. So if I square that out, remember this is a perfect square trinomial. So to get that, you just go x times x is x squared. That's the first term. To get the middle term, you multiply x times x and double it. So x times x is 2x. Doubled would be 4x. And then you square the last term, so 2 times 2 would be 4. Then that would equal then 4x plus 7. And before I get too far along, though, I got to remember there is a domain restriction. So let me get rid of this little arrow. Be a little bit. So notice that x plus 7 or x plus 2 would have to be greater than 0. So that means x has got to be greater than -2. And we have 4x plus 7 is greater than 0. So it'd be like 4x is greater than -7. X is greater than -7 fourths. So -7 fourths would actually be like, that's not even -2. So that's actually going to be the smaller domain, more restricted. So we got to be right in this -7 fourths. Because on a number line, if you graph a number line, the -2 would be here. The -4/7 would be like -1 3/4. So there would be like -1. So -2 would be here, and -1 3/4 would be located here. So that's a little bit more restricted in that sense. So we do have that domain restriction we have to pay attention to. So as I solve this, I have to be aware that we have to be, again, that's like -1.75 if we need a decimal remainder in that. Again, like I said, in my lab math, they don't like decimals, they like those fractions. So notice that I can subtract 4x on both sides, and notice how that middle term is going to zero out. So it gives me this x squared plus 4 is equal to 7. So it looks like to me it's easier to go ahead and just move the 4 over the other side and get the x squared by itself. So that turns into x squared equals 3. If I take the square root of both sides, we get x equals the square root of plus or minus the square root of 3. Now, the question is, do both of those work? I know the positive one works, but does the square root of -3, what is that? So if you take the square root of 3, that's 1.73. So -1.73 is actually smaller. It's to the right. So it's actually still part of my domain. So both those answers should satisfy this problem. They should both work. So we do have 2 solutions there, since neither one of them are outside of our domain restriction. So if I want to use a TI-84 calculator, I don't have one with me at this time. But what we can do is, if we graph each side, so if we want to graph y equals the log of x plus 1 base 5, and remember, we can also, notice how we don't have the same basis, so we can't put those together. You can type this in just as it is, because you do have that special key on the calculator. It's under the math menu that you can use to graph it that way. So if you go ahead and bring the 1 over and make this -1 is equal to 0, then all you got to do is really just use the 0 button on your graphing calculator, find the 0 of your graph, and that would be it. Now, if you can't find that special button under the math menu, again, in math, I think you have to scroll down to where A is. So you got to scroll down like 10 or 12 times or something. It's quite further down in the math. So you actually can type this in as it is. And then all you got to do is find the zeros from there. You also could use the change base formula, which would be a little more complicated. So this would be like base the natural log. It would be like the natural log of x plus 1 over the natural log of 5 minus the natural log of x minus 2 over the natural log of 4 minus 1. If you graph that, you should be able to find the zeros to that end and get it that way. So if I want to set this equal to 0, you can write like this is y equals e to the x plus x. So if you graph that, you should be able to find the zeros on your calculator in the graph area, and that should be able to locate the answer for you. So see if I can do that here. I'll pause for a second and put that into my calculator and see what answers I come up with. So you remember, as we do the zeros here, remember the left bound has to be left of the point of intersection. The right bound has to be on the other side of that point of intersection. On this graph, the left bound should be above, the right bound is below. And when you find that point of intersection, you should end up with negative 2.79 as the solution there for that. Now, again, we do have a domain restriction here. X has got to be greater than negative 1. And X has got to be greater than 2. So it's interesting that we actually did have actually 2.7. That's why I did it wrong. So yeah. So our domain actually knows how it's got to be the most restricted is X is greater than 2. So yeah, it wasn't negative. It's actually a positive 2.7. I just looked at it wrong. So it does check out. So yeah. So we do have a domain restriction there since it's a logarithmic function. The exponentials do not have domain restrictions. So when we do this one, again, when you do left bound, it should actually be below the x-axis. And the right bound should actually be above this time because of the way it approaches the x-axis. And the 0 there was a negative 0.57. So your solution to that one was that if you use the zeros key. Remember, the zeros key is under, if you do the second calculate button, that's where you actually find the zeros at. So to do the zeros, you have to do the second button and then calculate. And you got to make sure and again, the calculate button is above the trace button. So there's this trace button here that it's above. But if you have your normal window, so if you do zoom and you make it standard window, it should fit in that screen without an issue. So your window setting should just be zoom standard. I think standard is number 6. So under zoom, if you hit 6, the standard window should be your viewing screen for that. All righty, I'll stop there. Hopefully you will find that somewhat helpful as we move forward.